Hello everyone, welcome back to ASCII Math. So far we have learned indefinite integration. Now from this video it's time to explore this definite integrals where integration gives us a single numerical value and some interval will be given here. Okay, so let's begin and understand this concept step by step. First of all, in definite integrals we write integration from a to b. So here this a is called the lower limit and b at this top is called the upper limit, and as usual there will be some function which has to be integrated with respect to x. If the integral of this is capital F of x with some constant, so here we have to open this with our limit, that is lower limit a and upper limit b. So at first we have to always put the upper limit instead of this x. So it will be f of b plus c, and we have to subtract and put the value of x with this lower limit. So we will put the value of x as a. So it will be f of a plus c. So it equals to f of b plus c minus f of a minus c. So here the c and the c will get cancelled and we will only have f of b minus f of a, which will give you a definite value. And since there is no constant of integration, so that's why this integral is called definite. So while working with definite integrals, we always put the upper limit first and subtract by putting the lower limit. So let's see some examples. Question 1. Evaluate integration of x to the power 4 dx and my limit is from 1 to 3. So here lower limit is 1, upper limit is 3. So as usual, first we will integrate x to the power 4, and we all know that the integral of x to the power 4 with respect to x will be x to the power 5 by 5. Now no need to add constant of integration, but here we have to use these limits. So first putting x equals to 3, as 3 is our upper limit, so it will be 3 to the power 5 by 5, and we have to subtract by putting x equals to 1, that is lower limit, 1 to the power 5 by 5. So this equals to 3 to the power 5 is 243 by 5 minus 1 over 5. So this equals to 243 minus 1 over 5. Hence the answer is 242 by 5. Question 2. Evaluate dx over x squared plus 1 and my limit is 0 to 1. So this function is from our special integrals because we can write this as 1 by x squared plus 1 square dx. So this is in the form of 1 over x squared plus a square, and this equals to 1 by a tan inverse of x by a. So this is my answer, but we have to apply the limits from 0 to 1. So this equals to tan inverse of x on simplifying. Now let us use our upper limit. That means it will be tan inverse of 1 at first minus, and applying lower limit, that will be tan inverse of 0. So it equals to tan inverse of 1 is pi over 4 minus tan inverse of 0 is 0. So my answer is pi over 4. Question 3. Evaluate integration of square root of 1 minus sine 2x dx and lower limit is 0 and upper limit is pi over 4. So here this equals to 0 to pi over 4 square root of this 1 can be written as sine square x plus cos square x minus sine 2x is 2 sine x cos x and dx equals to 0 to pi over 4. Clearly this expression is in the form of a minus b whole square, so here it will be sin x minus cos x whole square dx. So this equals to 0 to pi over 4. So here this square and square root get cancelled, and I will have modulus of sin x minus cos x. Using the modulus sign because square root of any number is always positive. Now since my function is modulus of sin x minus cos x, and we know that this modulus of sin x minus cos x can be simply sin x minus cos x, or the negative of it, that is cos x minus sin x. Now since the value of x is from 0 to pi over 4, and between 0 to pi over 4 cos x is always greater, so this value will be positive. So therefore we will consider modulus of sin x minus cos x to be cos x minus sin x equals to 0 to pi over 4. So modulus of sin x minus cos x we will write as cos x minus sin x dx, because between 0 to pi by 4 cos x is larger than sin x, equals to, now let us integrate these two terms. Integration of cos x is sin x, and integration of sin x is minus cos x, so here it will be plus cos of x, and we have to use our limits. So it equals to, now let us first put the upper limit, that is pi over 4. So at first it would be sin pi by 4 plus cos pi by 4 minus, now we will use the value of x as 0, that is lower limit, sin of 0 plus cos of 0. So it equals to 1 over root 2 plus 1 over root 2 minus sin 0 is 0 and cos 0 is 1. So it equals to 2 by root 2 minus 1, and on rationalizing 2 by root 2 it will be root 2 and minus 1. So this is the answer. Question 4. Integration from 0 to 1 x into e to the power x dx. Now since there is a product of two different functions, so we will evaluate this using integration by parts. So at first we will simply integrate x e to the power x dx without the limits and using integration by parts. So here my first function will be this algebraic, and the second function will be exponential using I let c rule. So evaluating using integration by parts equals to first into integration of second minus integration of ddx of first into integration of second dx equals to x integration of e to the power x is e to the power x minus integration of ddx of x is 1 and integration of e to the power x is e to the power x only dx. It equals to x e to the power x minus e to the power x. Therefore, integration of 0 to 1 x e to the power x dx equals to, the answer is x e to the power x minus e to the power x from here. And since this is a definite integral, so we have to use the limits, that is 0 to 1. Opening this using upper limit, the upper limit is 1 here, so it will be 1 into e to the power 1 minus e to the power 1. So this is the use of upper limit, minus using lower limit, that is 0, it will be 0 into e to the power 0 minus e to the power 0. So it equals to e minus e minus this portion is 0 minus e to the power 0 is 1. So here e and e got cancelled. So it equals to minus of minus 1, and hence the answer is 1. Question 5. Integration from 0 to 1 e to the power x over 1 plus e to the power 2x dx. Here we will solve this integral using the method of substitution. So we consider e to the power x to be t. So this equals to, differentiating both sides with respect to x, we have e to the power x dx equals to dt. Now here one thing is that while doing the method of substitution, the lower limit and the upper limit also changes, because this lower limit and upper limit is for the variable x, and since we have changed it into a new variable t, so we have to find the new lower and upper limit. So when x is equal to 0, then t equals to e to the power x, which we have supposed, and this t equals to e to the power 0. Since we are putting the value of x as 0, so this equals to 1. And when x equals to 1, that is the upper limit, then t equals to e to the power x, that is e to the power 1, which is equal to e. So here when the lower limit was 0, then t equals to 1, and when the upper limit is 1, that is when x equals to 1, then that time t is equal to e. Therefore my new integral will be integration of 1 to e, and e to the power x dx is dt by the substitution, whole divided by 1 plus e to the power x is t, so here it will be t square. So while doing the method of substitution, you should also change the limit. So it equals to, now this is in the form of 1 over x square plus a square. So the integral of this is tan inverse of t by a, so t by 1. But since we have to apply the limits, so here it will be 1 to e, and putting the upper limit, that is e, we will have tan inverse of e minus tan inverse of 1, and this equals to tan inverse of e minus tan inverse of 1 is pi over 4. Question 6. Integration from 0 to pi over 2 cos of x over 1 plus sin x into 2 plus sin x dx. So using method of substitution, we first assume sin x to be t, and differentiating both sides, we will have cos x dx equals to dt. But we have to change the limits also, because the value of x is ranging from 0 to pi over 2. So when x equals to 0, that is low limit, then t equals to sine of 0, that means t is equal to 0. And when x equals to upper limit pi by 2, then t equals to sine pi by 2, that is t equals to 1. So my new lower limit and upper limit is from 0 to 1. Therefore I equals to, my new limits is from 0 to 1, cos x dx is dt divided by 1 plus sin x is t and 2 plus t. Now to integrate this, we will use the partial fraction which we have learned in previously. So this equals to 0 to 1. So if I do the partial fraction here, then this will be separated 1 over 1 plus t minus 1 over 2 plus t dt. Now this you can do by yourself. I am skipping that part. So this equals to, now if I separate this integral into two terms, then integration of 1 by 1 plus t will be log of 1 plus t minus, and integration of 1 by 2 plus t will be log of 2 plus t. So this would be my final answer if I integrated them, but since here this is a definite integral, so we have to use the limits also. So my upper limit is 1, so instead of t I will be using 1 here. So putting upper limit, it will be 1 plus the value of t is 1 minus log of 2 plus 1. So here I use the upper limit and we have to subtract and put the lower limit. So putting lower limit here, it will be log of 1 plus of 0 minus log of 2 plus of 0. So this equals to log of 1 plus 1 is 2 minus log of 3 minus log of 1, opening the bracket, minus and minus will be plus log of 2. So this equals to, here the first term and the last term, that is log of 2 plus log of 2 will be 2 log of 2 minus log of 3, and we know that log of 1 is 0, so this is 0. So that means my answer is 2 log 2 minus log 3.
Question 7. Evaluate integration from 1 to 2 dx over x into 1 plus log x whole square. Here the derivative of log x is 1 by x, so we will substitute log of x with equal to t, and differentiating both sides we will have 1 by x dx equals to dt, and changing the limits when x equals to 1, that is lower limit, then t equals to log of 1, which is equal to 0, and when x equals to 2, then t equals to log of 2. Therefore my integral I will be equal to, range is from now 0 to log of 2, and dx over x is dt divided by 1 plus log x is t whole square. So this equals to integration of 1 over t square is minus 1 over t. So here it will be minus 1 over 1 plus t. Since 1 plus t is a linear polynomial, that's why we can do it directly. And we have to divide with the derivative of 1 plus t also, that is simply 1, so we will just ignore that. But here we have to put the limit, that is from 0 to log of 2. So to avoid confusion, let us take out minus common first. 1 over 1 plus t, 0 to log of 2. Now we will put the upper limit, so it will be minus 1 over 1 plus log of 2 minus, putting the lower limit, that it will be 1 over 1 plus 0. So opening the bracket with minus, then we will have minus 1 over 1 plus log of 2, minus minus is plus, and here it will be 1. And doing the LCM, we will have 1 plus log of 2 and minus 1 plus 1 plus log of 2. So here plus 1 minus 1 gets 0. So my answer will be log of 2 by 1 plus log of 2. Question 8. Evaluate from 0 to pi over 2 square root of tan x plus square root of cot x dx. So before substitution here, we will simplify the given function. So this equals to 0 to pi over 2. Let us write square root of tan x as square root of sin x over cos x, and cot x is cos x over sin x dx equals to 0 to pi over 2. Taking LCM here, we will have square root of cos x into square root of sin x. So we will write square root of sin x into cos x
And in numerator we will have square root of sin x into square root of sin x, that will be sin x only, and similarly here it will be cos x dx. Now let us multiply and divide with square root of 2. So it equals to square root of 2 outside, 0 to pi over 2 sin x plus cos x divided by square root of 2 sin x cos x equals to square root of 2 from 0 to pi by 2 sin x plus cos x whole divided by square root of, let us add and subtract 1 here in denominator, plus 2 sin x cos x dx equals to square root of 2 integration from 0 to pi by 2 sin x plus cos x whole divided by square root of, let us take out minus common here, then it will be 1 minus 2 sin x cos x dx equals to square root of 2 0 to pi by 2 sin x plus cos x whole divided by square root of 1 minus, now instead of that 1 we can write sin square x plus cos square x minus 2 sin x cos x dx equals to square root of 2 integration from 0 to pi by 2 sin x plus cos x whole divided by square root of 1 minus, this everything is in the form of a minus b whole square, so we will write sin x minus cos x whole square dx. Now we will substitute this denominator term, that is sin x minus cos x, to be t, and on differentiating we will have cos x minus dx of cos x is minus sin x, so it will be plus sin x dx equals to dt. Changing the limits, when the lower limit, that is x equals to 0, then t equals to sin 0 minus cos 0, that is t equals to 0 minus 1, that is minus 1. And when x equals to upper limit is pi by 2, then t equals to sin pi by 2 minus cos pi by 2. So this gives the value of t equals to 1 minus of 0, that is 1. So my new limit is from minus 1 to 1. Therefore my integral I equals to, see there is a square root of 2 outside, so we will write that, and the limit has been changed from minus 1 to 1, and sin x plus cos x into dx in the numerator is dt from this equation. So numerator is dt divided by square root of 1 minus sin x minus cos x is t, so here it will be t square. So this equals to integration of 1 over square root of 1 minus t square is sine inverse of t, and the limit is minus 1 to 1. So this is the direct formula. So now let us use the upper limit, then it will be sine inverse of 1 minus, using lower limit, sine inverse of minus 1. Now for this we should know the principal value range of sine inverse function, that is from minus pi by 2 to pi by 2. So square root of 2 into sine inverse of 1 is pi by 2 minus, and sine inverse of minus 1 is minus pi by 2 equals to square root of 2 pi by 2 plus pi by 2. So this equals to square root of 2 into pi by 2 plus pi by 2 is 2 pi by 2. So 2 and 2 got cancelled. Therefore, the answer for this question is square root of 2 into pi. This much in this video. In the next video, we will start the properties of definite integrals, which is very important. So till then, keep practicing.